Okay, we'll now be doing question 11. The volume of the cone is given by the formula. Okay, so in A math, they always give the formula for volume of cone. Okay, the diagram shows a vertical cross section of a cone in the form of a cone height 25 cm and base area of base radius of 15 cm. Okay, so the container is initially empty. At t equals to 0, the liquid is allowed to flow through a small hole close to the vertex. Okay, that means over here, this is the vertex. Here, the water flows through here. After t seconds, the height of the liquid in the container is 25 minus x, and the volume of liquid is given by V. Show that V is given by this expression. Okay, so how do we find the volume of the water, right? What is the concept that we have here? Right, the volume of the water, this which is the shaded area, the shaded part that they give you, is given by the volume of the entire cone minus away the empty space above, right? So you don't really have a formula to find the volume of the water directly, but you know the volume of the water is given by the volume of the cone minus the empty space on top, right? So that is the concept that you have to use. Volume of water given by V is equals to volume of cone minus volume of empty space. Okay, so the formula for volume of cone given by the question, 1/3 pi r square h. Okay, in this case, the radius of the cone is 15. It's already given to you, so you can directly sub in. The height of the cone is also given to you to be 25. Okay, then minus away 1/3 pi. Okay, what is the radius of the empty space? Okay, so this is the one that you don't really have information of. Okay, and then the height of the empty space is given to you by x. So now the question mark is, what is this radius of the empty space, right? So let's stare at our diagram for a while more. I need an expression for this radius, which I don't have. Okay, and then if you look at the clue in the question, show that V is equals to this. You realize that it's only an expression in terms of pi and x. There's no other variable r involved, right? So this gives you that idea of, oh, I need to find an expression for radius, in this case the radius of the empty space, in terms of x, right? So what other concepts have you learned before that can help you solve this question? Right? What other concepts, what topics have I learned before? Okay, and by this time you should have registered that there's actually similar triangles involved, right? We have been doing this many times, isn't it? Okay, so if you can't see it, then I'm going to draw it out for you to see. I'm trying to draw. Okay, great. So this is 15. This is the unknown radius that I want, and then I know that this is x, and this whole thing is 25. Okay, so by similar triangles, I can then write r over 15 is equals to x over 25. Okay, by similar triangles. So r will then be equals to 15x over 25, which can then be simplified to 3x over 5. Okay, done. So this I can now sub in as 3x over 5. Okay, sub this into our formula. And then I can simplify this to show the answer. So I'll leave the simplification to you, do yourself, and then you should be able to get it to look like this. Okay, shown. There's some simple manipulation that you all should be able to do. Okay, part 2. Given that the rate of flow of the liquids is kx square. Okay, so rate of flow of the liquid is kx square. x cubed over s. What is this information given? If I write it in mathematics sense, right? So it's dv over dt. So this is dv over dt, right? Where k is a constant, find an expression for dt over dx in terms of pi and k. Right, so now they want dt over dx. Usually we find dx over dt, right? But the dt over dx is just the reciprocal of it lah, so it doesn't matter. Okay, so we can find this, then we just take the reciprocal. All right. So what concept do we know about this? Rates of change, right? And we know that dv over dt is given by dv over dx times dx over dt, right? So from here, we are already given dv over dt. Done. Then what is dv over dx? We don't have it, but we can find it from part 1, right? Can be found from part 1. Okay, then we just have to differentiate the expression in part 1. And then dx over dt, that's what we want. So we can easily solve that once we have the first two things settled. Okay, so first let's do our dv over dx first. Oops, sorry. So let's differentiate first. Okay, dv over dx. Differentiating this expression. How do we differentiate this? Okay, maybe I don't skip steps. Let me expand and show you all first. So v is given by this expression. If I expand it, I will be able to get 625 is what? 1875 pi? I think so. It doesn't matter, right? Actually, why am I even bothering to do this? It is a constant. Okay, so if I expand, I'll get this. Please don't use product rule. 3 pi is a constant. Okay, so you can just expand and after that differentiate it. Right? Don't need to bother to use product rule. So dv over dx. Okay, first term is constant, so it's gone. Negative. Bring down the power, so times 3 becomes 9. Power minus 1. So you should be able to get this expression for dv over dx. Okay, so now we can sub it into our expression. dv over dt is given by kx squared. So kx squared equals to negative 9 pi x squared over 25 times dx over dt. So therefore, dx over dt is equals to kx squared divided by this expression, which can then be simplified to keep change flip. Oh, the x. Oh, x nicely cancels each other out. So I'm left with 25k pi over 9 negative. Oh, sorry. The pi should be at the bottom. Yeah, because we divide the 9 pi over. So over 9 pi, even better. Okay, and then because I want dt, the question wants dt over dx. So therefore, dt over dx is negative 9 pi over 25k. We just take the reciprocal. Done. Okay, so that's the answer for part 2. Okay, last question or last part, part 3. The liquid was allowed to flow for 72 pi seconds when the height of the liquid reaches 12 cm. By expressing t as a function of x, find the value of k. Okay, so the liquid was allowed to flow for 72 pi seconds when the height of the liquid reached 12 cm. Okay, so what does that mean? So this is telling you that T, okay, when the liquid was allowed to flow for 72 pi seconds, right? So this means that T is 72 pi. When the height of the liquid, okay, what is height of the liquid? If you read the question properly, is the height of the liquid x, or is the height of the liquid 25 minus x? Okay, if you read this sentence, height of the liquid is actually 25 minus x. So this is the tricky part, because a lot of students are going to think that x is 12. It's not. Okay, it's actually 25 minus x is 12, which means that x is actually 13. Okay, so that is the gist of this question. Okay, so now the problem is, how do we find how do we express t as a function of x? That's the hint given to us in the question, right? By expressing t as a function of x. How? What's given to you in the question, or what have you found in the question that is useful to you? Okay, you don't have to look too far. It's in part 2 of the question, right? dt over dx is given by this expression. So if I were to integrate this expression, okay, so let me write down, by integrating dt over dx with respect to x, we can find an expression for t as a function of x, right? So if I can just integrate this expression, I will be able to get the answer that I want. Okay, so integrating this, 9 pi over 25k is just a constant. So this one just simple, right? Becomes x plus c. Okay, now the question is, how do I find c? What's given to me in the question that can help me find c? What information is given to me in the question? So you have to read the whole thing again, right? So we're going to at time t equals to 0. Okay, so this is the part. At time t equals to 0, liquid is allowed to flow through a small hole close to the vertex. Okay, so what do you know about time t equals to 0? At time t equals to 0, what is the height of the liquid? 0, right? There's no water inside. The container is initially empty, right? So if the container is initially empty, at t equals to 0, what is the x value? 25, right? Because the height of the liquid is 0. So 25 minus x is 0, which means that x is 25. Okay, so this is the hidden information in the question that will help you find c. So at t equals to 0, x is 25. Sub it in lah. Then you can solve for c. So c is 9 pi over k. Okay, so now that we have found c, therefore t is negative 9 pi over 25kx plus 9 pi over k. Okay, then the question says find the value of k. Like, then what's given? The liquid was allowed to flow for 72 pi seconds when the height of the liquid reaches 12 cm. Okay, so that's the last information given to us in the question. When t equals to 72 pi, x is 13. So let's sub that in. 72 pi equals to negative 9 pi over 25k bracket 13 plus 9 pi over k. Right, and can solve this. I can divide the k away. So I will get 72 minus equals to, okay, because I divide the k away, then these two become like terms, so I can add them up. I'll get 4.32 over k, which means that k is 0.06. Okay, and that's our answer. Okay, that's it for this worksheet.